Welcome, ladies and gentlemen. Thank you for joining us today's FIBERTalk webinar series. I'm Rasafi Alam from FTTH Council Asia Pacific here with you. I hope everyone is doing fine. Today, our webinar topic is 5G oriented conduit solution. In today's webinar, we will analyze the source of massive fiber optical demand in 5G era, illustrate the problems of the existing conduit resource, compare existing conduit solution, and introduce a 5G oriented conduit solution, which is OptiCell Max, MX. So we have been joined by Paul Kohn today. He is the sales manager, cable for Asia in Millikin, and his colleague Kai Chen will be assisting him for the presentation as well. So Paul leads the sales activities and provides technical support for OptiCell / MaxCell flexible fabric inner duct solutions and OSP cabling since 2004 in North, South, and Southeast Asia. So before I hand over to Paul, we will have a Q. So just for your information, we will have a Q&A session at the end. If you have any questions or queries, please do not hesitate to ask in the questions box. And at the Q&A session, we will definitely try our best to answer all your queries and questions. So now I'm handing over to Paul for his presentation.
Thank you. Nice to meet you, everybody. Kai, would you mind starting the presentation, please?
Okay.
All right, hello, my name is Paul Kohn of Millikin and Company. And I'm joined today by my colleague and technical specialist, Kai Chen, to talk a little about the current and future state of communications and the implications it may have on the current OSP infrastructure. But before I start, a little bit about the organization I belong to. Millikin is a 156-year-old company based in the US, specializing in textiles, chemicals, and industrial and specialty fabrics. And OptiCell or MaxCell is one of those specialty fabric products serving the cabling market. OptiCell is a fabric compartment for cables, both for outside plant and indoor applications. And while one of our largest customers is telecom, we also serve the military, power and utility, cable TV, enterprise, ITS, data center, government municipality, security and city surveillance, airports and highway markets. Basically, anyone who deploys cables into conduits can use our solution to maximize the efficiency and profitability. Cables ranging from 2 millimeters OD to 45 millimeters OD can be installed in OptiCell. Next slide, please. Whether it be that available technology creates demand or vice versa, it seems that the advancements in digital communications is allowing improvements in various aspects of our lives. From health, safety, security, commerce, finance, industry, to entertainment and mere convenience, digital communications has never played a role as it is starting to do now, especially as we enter the 5G era. Technologies and lifestyles built on the speed, processing capabilities, and the stable reliability of communications will be part of how we live in many parts of the modern world. Next slide, please. When we talk about mobile, we tend to focus mostly on the wireless part. Mobile phones, antenna technology, base stations, etc. However, optical fiber is the foundation of mobile communication, which connects all the segments of the network. And as the fastest and most reliable transmission medium, optical fiber will remain as the foundation of the network in the 5G era. And when we look at the current 5G model, along with the many generations of communications upgrades to follow, From an infrastructural point of view, we may notice that a great deal of work is being done at the latter end of the network structure. However, we may also notice that unless there is a major shift in the nature of communications technology, the basic framework of the current infrastructure is and will continue to be based on optical fiber. Next slide, please. The construction of true 5G will take a long time. At the initial stage, lower frequency is adopted to rapidly realize continuous coverage. This means that the infrastructure of 4G can be used and not much optical fiber demand is expected. But if we look at the middle and later stages, to completely realize all the 5G applications, higher frequency millimeter wave will be required. Frequency is inversely proportional to coverage. Compared to 4G, more base stations are expected to cover the same area in 5G. The connection of these extra base stations will bring more optical fiber demand. Also, as 5G further develops from its initial stage to more advanced stages, we can also expect to see a gradual, if not rapid, increase in the demand for optical fiber, due to the coverage that the higher frequency-based communications requires. Unlike 4G though, the backhaul mode of 5G is different, as the BBU and RRU are divided again into AAU, DU, and CU. The deployment of DU and CU can either be standalone or centralized, depending on the business needs. Standalone deployment will generate more transmission requirements, resulting in more optical fiber requirements. The method of infrastructural deployment may also change in the future, depending on the maturity of the stages and also on the target end users of the infrastructure. Next slide, please. To meet the needs of 5G business, the transmission network also needs to be upgraded. No matter what transmission technology is used, there will be high demand for optical fibers. In the core layer, there will be small fiber demand as the positions of core equipment are relatively fixed. Hence, the convergence layer will be primary source of fiber demand in the initial stages to set up the transmission network architecture. And in the access layer, gradual increase in equipment will bring new fiber demand. One thing is clear, as long as we continue pursuing the supply and demand and further development of the various social interactions and activities that our current state of communications permits, the demand for fiber will most likely grow to support that pursuit. As a part of the 5G network, the transmission network must be upgraded to meet the transmission needs of 5G service. No matter what kind of new transmission technology is finally adopted, it will bring new fiber demand all the way from the access layer to the core layer. In other words, higher frequency, new backhaul modes, and the upgrade of the transmission network will bring massive optical fiber demands in the 5G era. Next slide, please. We, as a company mostly dealing with OSP cabling, look at this future forecast first from a conduit-based perspective. With the many restrictions on building new underground communication infrastructures such as conduits, and with so many pre-existing infrastructures either low in supply, congested, or simply exhausted, how will the infrastructure owners or cable owners deal with the upcoming demand for new fiber? The conventional method of cabling in OSP conduits has been in many parts of the world subducting. This started, of course, before we realized how much fiber the telecommunications technology would eventually need, and has resulted in many cases as a waste of potential available space for additional cables. Also along the way, some regions allowed cable over cable, and this presented the problem of cable wrapping, causing the conduit to become useless before it could reach its full space providing potential. With limited space and limited infrastructure, How then do we address the upcoming massive demand for more fiber deployment? Next slide, please. There are a few methods of common use that we have seen as early on as during the 3G era. Pushing ahead with new build is one example. Reorganizing the existing cables to accommodate more fiber is another. Shared infrastructure or shared cables is being practiced in some places. And we have also seen new ideas and technologies adopted to try and bypass these obstacles that the above mentioned present. However, each method has its downside. New build most certainly involve high cost and complicated permit issues, not to mention a lengthy planning and implementation period. And sharing infrastructure would involve issues like the responsibility of the physical asset. As a side note, we are quite familiar with all of these methods as our product solution has been widely used to A, increase cable density in new build projects, B, used in cable replacement projects, C, used for adding cables in conduits that were thought as fully occupied, D, used for cabling in small ducts and subducts, and E, even for aerial cable or non-pole projects globally. And one thing we have observed during our service in this field is that preserving and carefully planning ahead for the available space of the conduit asset is probably one of the most important measures of precaution the asset owner can take in relation to the upcoming increase in fiber demand. Before I go on further, I'd like to introduce a little bit more about the solution we have been providing our international customers. OptiCell or MaxCell is a multi-cell flexible fabric subduct solution that eliminates the space wastage of conventional rigid subducting in conduits, while also eliminating the hazards and unpredictability of the cable over cable installation method. It can be used for new build, existing empty conduits, and also occupied conduits to fully and safely maximize the number of cables deployed in the conduit or rigid subduct. Since OptiCell conforms to the shape of the cable and is available in various sizes, the user can afford to experience the least amount of wasted space and would be able to invest as the demand for fiber increases. The compartments or cells also act as dedicated pathways for the cables. Therefore, none of the cables inserted would physically touch one another or wrap around one another. Safely maximizing the available conduit space efficiently when demand is imminent is what the solution does for its users. The diagrams that you're going to see on each slide from now on represent cross-sectional depictions of conduits, subducts, and the product OptiCell. We have also recently introduced a new product line called MX, which is a mini version of the standard OptiCell. MX is mainly used in small ID conduits or rigid subducts to increase the cable density. And similar to the standard OptiCell, which is used in the main ducts, OptiCell MX can be used in smaller conduits for reducing the overall investment cost in new build, maximizing cable density in empty conduits, and revitalizing conduits where they were thought initially to be too full for future use. Next slide, please. In many countries, especially in Asia, we are seeing a trend of communications cables getting smaller in OD and higher in fiber density. Inevitably, the asset owners may be forced to make use of every inch of available space in their underground OSP infrastructures to accommodate the growing demand of fiber before more drastic measures are needed. And this is where we can help. By looking at the fact that our application market is expanding from main conduits to smaller ID conduits and even rigid subducts, we can see that the demand for underground space that 5G and its future upgrades will require is imminent. Slide 11 shows us an example of how our newly launched MX solution can assist with the empty conduit situation, maximizing the number of cables or in other words, the number of fibers that can be installed, where traditionally one cable would be installed in the conduit. The gray circle in the slide represents a small conduit or a subduct. Typically, the common method of cabling would be to install one cable into one small conduit or subduct, regardless of the cable size. Attempting to add an additional cable later into this occupied small conduit or subduct could present great difficulty or even serious damage to either of the cables. However, as you can see, the MX solution allows the user to compartmentalize the available space for the safe deployment of cables in the future. Slide, please. Similarly, slide 12 shows how an occupied conduit can be further utilized using the MX to install additional cables into this occupied conduit. Conventionally, this occupied conduit would be considered unusable for additional cables, whereas MX will allow a low friction fabric barrier prior to the development of the additional cables in the occupied conduit, since none of the cables would be physically touching one another. This, however, is a more difficult application than compartmentalizing a conduit right from the beginning when it is empty. And we always encourage our users to use the solution in a clean and empty conduit right from the beginning to ensure the most desirable results. However, this is possible. Next slide, please. Slide 13 is an example of how the cable owners conventionally would replace cables with larger core cables, where an alternative can be installing an MX multi-cell into the conduit while pulling out the existing obsolete cable, hence making dedicated cable pathways for future expansion. This application, in a sense, is also an example of full space recovery of the existing infrastructure and can greatly help the user to maximize the service life and the service capacity of their assets. Next slide. And the next slide, slide 14, deals with new construction, new build, where the high cable density capabilities of MX can allow the user to reduce the number of conduits needed when the new construction of the underground infrastructure is absolutely inevitable. In other words, if you must build an underground infrastructure, we can help reduce the overall project size and the cost. If either OptiCell or MX is utilized in this new build application, numerous cost calculations have shown the infrastructure owner can actually save most on the investment cost. And depending on the total size of the network under consideration and the number of conduits that had been initially planned, the savings realized can amount to enormous numbers, not to mention the tremendous amount of time saved as well. Next slide, please. So, while the standard OptiCell product mainly serves our users in the main conduits, we have had increasing usage of the smaller MX product with our users for cables of 12 millimeters OD or smaller in small conduits or subducts of 28 millimeters ID or larger. So we've just prepared just a couple of examples. My colleague Kai here will now briefly walk you through a couple of these examples of MX usage in subducts where the user realizes the full maximization of the subduct space. Care to explain?
Okay.
Niels, please.
So this application was a 30 millimeter ID empty P subduct. Due to the ID tolerance, the actual ID of the subduct varied between 28 millimeter and 29 millimeters. The road consisted of 3 subsections that were approximately 32 meters, 8 meters, and 40 meters in length. The 8-meter section was extremely difficult to route. The contractor told us that these 2 bands in the section were not 90-degree bands, but actually an asphalt. resulting in each band being closer to a 180-degree band. It was apparent that this was either true or perhaps each band being a 90-degree with a very tight band radius. One pack of opticell MX was manually installed in the 80-meter rod in less than 1 minute. The product was not terminated in the two intermediary handholds H2 and H3. Finally, a total of 4 9.2 mm OD 100 core WTR cables were installed in the opticell. The first cable in the opticell was installed manually in 2 minutes. The cable could be pulled all the way with one hand, and the pulling tension was approximately 5 kilograms. That of the fourth cable was only 25 kilograms at the 80-meter mark. The 8-meter section did provide more difficulties for the cable 3 and the cable 4 installation, and an assist point was made at handhold 3. However, the sudden increase in drag at 2 band points disappeared when head of the cable 3 and the cable 4 passed out of handhold 2, suggesting that these 2 bands in this section were not typical 90-degree bands you would find in telecom structures. This rod was an extremely severe case, and the product MX proved that it could protect the cable with very low pulling tension and allow the user to fully maximize the available space by installing 4 cables. By traditional method, customer can only install one WTR 100 core cable in a 30 mm IDP subduct. However, by one pack of opticell MX, a total of 4 100 core WTR cables can be accommodated. Fiber density is also increased at the same time, which provides lots of confidence to the customer for 5G cabling. So the application in this slide was also a 30 mm IDP subduct, but the cable applied is a combination of regular cable and air-blown cable. The rod was 75 meters with 2 90-degree bands. The first band was a horizontal band, and the second was a vertical band going up to the RCU. Due to the obstacles inside RCU, the pulling had to be done at a right angle to the subduct's entrance in the RCU, resulting in a third tight 90-degree band. One pack of opticell MX was installed into the P subduct and pulled. And finally, a total of 4 cables were installed. 3 9mm OD 48 core regular cables and 1 6mm OD 96 core air-blown cable. The capacity was increased to 400%, while the fiber density was also improved. Due to the limited space inside RCU, 2 men pulled cables while sitting on the floor. The cable pulling had to be done very slowly to prevent any damages to the existing equipment or wires inside. And the maximum cable pulling tension did not exceed 30 kilograms. The air-blown cable has no damage due to the low pulling tension. This installation was conducted to demonstrate that customer will be able to install multiple ADSS cables, drop cables, and even air-blown cables in their P subducts, and efficiently maximize the available space. Paul.
Okay, thank you, Kai. So before we go into Q&A, just to help with your better understanding of, I'm not sure if people here today are from the OSP background, but just to give you an idea of what we're talking about, if you're not, we just prepared 2 photos. The photo on the left you see on the screen is a typical 4-inch or 100mm PVC pipe that is commonly used in telecom and also in other industries. Conventionally, typically, people would use rigid PE subducts to compartmentalize before inserting the cables in. And well, depending on the cable size, and the cable sizes are getting smaller these days, you would put anywhere from 3 to 4 to even now 7 rigid subducts in. However, that still means that you can only put 7 cables into this 4-inch pipe. What you see here is a 12 cable installation. We haven't fully utilized all the space there. We haven't occupied all the space there, but to give you an example, if we're talking about a 144 core standard loose tube, let's say 16mm cable, our product, this photo you see on the left is the standard OptiCell. That can help you put maybe 17 cables into a 4-inch pipe in the typical OSP, under the typical OSP conditions. And on the right, what you see is actually a PE subduct. That is a 30mm ID or 34mm OD PE subduct. And these, I believe, are WTR cables going in, about 9mm. You could also call them SWR cables, spiderweb ribbon cables. And we've inserted 4 of them into the PE subduct, where conventionally they would put in 1 cable. So I guess the message for today, and we're going to wrap up, is we've been servicing the OSP industry for quite some time now, and given the direction and the nature of where 5G is going, we do see that there is going to be congestion issues coming up. There is a limited amount of space available. And as the cables grow smaller, and there are many different types of cables, we do see our users struggling to use every last bit of extra space that they can find. And just so that you keep in mind, there is a product called OptiCell. There is a solution called MX that can help users when they face this dilemma. So that's all we prepared for today. And if you have any questions, we'd be happy to answer your questions to our best ability. So I'll hand it back to you, Rasfi.
Thank you, Paul. That was a really nice presentation with some real insights. So, the audience, if you have any questions or queries on to ask, so you can just go to the question section of the panel and write your questions, and we will try our best to discuss. So, to Paul,
I'm sorry, I'm hearing a lot of background noise. I can't hear what you're saying.
I think it's coming from Joe and Paul. Kai, can you hear me?
Yeah, I can hear you, but not clear.
Okay, I see.
Yeah, I don't think it's from here. It's okay now. I can still hear a faint buzz.
Okay, can you hear me? Just give me a second.
Yeah, it sounds to me. It sounds like feedback when a microphone is too close to a speaker. Has he logged off?
Can you hear me?
I can hear you.
Is it okay now?
There's still a buzz, but I think we can just continue on. If you speak loudly, I think I can hear you.
Yeah, sure. So we will now move to the Q&A session. So I think we have started getting some questions well from the audience side. So I have some questions from my side. So first question would be to Paul, that what's the difference between MX and regular optical TM?
Did you hear that, Kai?
No.
Could you repeat, please?
Can you hear me now?
Yes.
So the question is, what is the difference between MX and regular optical TM?
Okay. I think the first difference is the size. Our regular optical is mainly focused on 3-inch or 4-inch high conduit. However, our optical MX is more focused on small size conduit like 28 and above ID conduit, small duct. And the second is the structure of the product. The stitch lines is moved into the middle to reduce dead space. Thus, we can make better use of the duct space. That's all. Thank you.
Okay, thank you for the answer. So the next question is there cable compatible with MX series?
Yes, we can see there are many cables for sale in the market that are compatible with MX series. For example, WTR cables, air-blown cables, and even regular cables with low fiber count is compatible with MX.
If I could add to that, basically, we don't really think about the type of cable because we've actually installed Cat5 UTP cables in the product, drop cables. So for the MX, it's basically about the size of the cable. And also the standard OptiCell product is also really about what size cable do you want to deploy, and you pick an appropriate size product for that cable. Not necessarily the cable type.
Okay, great. So that answers the question. So the next question is MX installation different from regular OptiCell TM installation?
From the installation perspective, they are the same, right, Paul?
Yes, the installation method is pretty much the same. routing the duct, and then you could either manually pull. Many of our customers, since they're based in Asia, either pull or use a small winch. But the winch is not necessarily because it's hard to pull, it's because something they have. And most of the installations are very, very easy, smooth pulls. So everything can be done manually under the typical OSP conditions, and there is not much difference between an MX installation and a standard optical.
Okay, great. So the last question, how to distinguish the forces?
We have pre-inserted a rope with color in each cell. That means we have 4 different colored rope in 4 cells: white, orange, blue, and yellow.
Okay, got it. So I think we are not seeing any questions coming. So if that is okay, we can conclude today's session. So we'd like to thank Paul and Kai for a very interesting session on the 5G Conduit solutions. We really appreciate, and we'd like to thank all of our audience who have attended today. So for any queries or questions, if you have any, you definitely can directly reach out to Paul and Kai through their email. It's on display. And the recording will be shared to the audience as well. It will be circulated shortly. And about our next webinar, we will announce that soon. Please stay connected through our social media and website. So with that, I'd like to conclude today's session. Thank you, Paul. Thank you, Kai, for today's session, for your time. So goodbye to everyone. Thanks a lot.
Thank you, everybody, for your time, and stay safe.